In this screencast, you're going to be comparing multiple functions. So on this side, we have Mr. Rich recently planted a crop of money trees in his garden. So we have tree A as one function, tree B is another one, and tree C. So tree A is just a word problem representing the function. B, we have a table, and C, we have a graph. So in order to kind of start comparing them, we first should read tree A. So the first tree was 5 inches tall when it was planted. It has grown 4 inches every month since being planted. So if you kind of like think about a tree, like say here's our little tree, it was 5 inches tall when it was planted. And then it grows 4 inches every month. Okay, so here's my awesome little tree. And now, like in the next month, it grows 4 inches, which really means it's 9 overall. So using that, I'm going to kind of erase this and maybe make a table so I can see what's happening. So if the tree, we have months and the height, if when it's planted it's 5 inches tall, that means there's no months. But then we just talked about, well, after 1 month it's going to be 9 because I have to add 4 inches to it. And then 2 would be 13 because again, I'm adding 4 on this side and this side I'm adding 1. And then I could just say like 3, 17. That gives me enough data points to compare. So I can see on my left and right side that there's a pattern. Just talked about that my left side, my months is going by 1, my right side for inches is going up by 4 every time. So we know it's 4 inches every month. That will help me determine some information about the other trees and being able to compare them all together. So tree B is already in a table. So I can kind of see that from here, it's going by 2, then it goes 1, then it goes 2. So the pattern is not as consistent, but I can still compare these. From 3 to 12, it's 9. Here, it's 4.5. And then I could keep going if I wanted to. But right here shows me what's happening. So again, we know it's when it's planted, it's 3, but that we have to find the pattern. So I can either compare 9 over 2 and get 4.5 inches in a month, or what I circled also tells us our constant rate of 4.5 inches every month. Then our last one is our graph. So I'd like to see it more in a table format. So here we have 0, 10, so then we have 2, 17 is the next point, 3, 20.5, and I could keep going, but again, I have enough to help me. So here we're going by 2, here we're going by 7. So 7 over 2, 7 divided by 2 would be 3.5 inches every month. So go ahead and pause and try to answer 1, 2, and 3, and then play when you've finished. Okay, so based off of all of my unit rates, my constant rate for each tree, I can see that tree B is growing the fastest because tree B is growing 4.5 inches per month. Then in number 2, which tree was the tallest when it first was planted? Well, here it was 0.3. Here it was 5 inches. and here it was 10. So tree C, 10 inches would be the tallest. Now, this third question really hits these like function rules. So kind of taking it back a step, the rule for tree A to figure out its height, we kind of have to figure out how am I getting 0, 5, 1, 9, 2, 13. And this is going to help us going into the next chapter. But I know I'm multiplying by my constant rate, and then I need to add that 5 that it originally was when it was planted, and it will give me my height. Where tree B, I need to multiply by 4.5, add the 3 inches it already was to get my height. And the very last one, I multiply by 3.5, add my 10 inches to get the height. So if I go down and use all 3 of those rules, A would be 4 times 6 plus 5. B would be 4.5 times 6 plus 3. And then we'd have 3.5 times 6 plus 10. So then if you do the math, we're saying that this would be 29 inches. 6 times 4.5 plus the 3 would be 30 inches. And then I should be getting 31. So that means tree C should be the tallest after 6 months. Okay, so you just compared 3 functions to answer some questions. Turn it over, and this time we're going to be talking about pizza. So we can't copyright Domino's, Little Caesars, and Papa John's, so the names are a little funny, but Tony is the best pizza delivery man in the city, and he's been offered jobs by the best pizza places. So we have Bambino's, Little Squeezers, and Papa Ron's. Same idea. So you could pause and see if you could figure it out on your own to compare them so you can answer the questions, or you can follow along with me again. So I want to write that rule. So here we're saying, okay, my cost would be, he gets $2.50 in commission. We don't know that commission. Plus $56 per shift. The next one, we got to do a little bit more work. So I see my changes 2 and 6. So salary over pizzas means we're getting 3, not 6, 3. So this would be, our rule would be 3 times however many pizzas or commission plus the $48 he gets in salary, because here's that initial amount he's going to get. Then the very last one, we have a change in 2 and a change in 4. So 4 divided by 2 would be $2 per pizza. So my rule would be $2 per pizza for that commission plus the 60 he gets automatically. So again, you could pause now and see if you could figure it out. And so in number 4, which company pays best per shift? Okay, so option A, he gets 56 no matter what. B, he gets 48. And C, he gets 60. So Papa Ron's, no matter what, per shift, he's going to get the most. Which company pays the most per pizza? Well, we kind of got our answers here. $2.50. That would be Little Squeezers. Because they charge $3 a pizza. Okay, and then you can use your rule again to do all your math. So option A, if we're going for 20 pizzas here, 250 times 20 plus the 56. 3 times 20 plus 48. Or C would be 2 times 20 plus 60. So 250 times 20 would be 50 plus 56. I'd get 106 from Bambino or Bambinos. 3 times 20 is 60 plus 48 is 108. Oops, I kind of messed up some parentheses in C, but 2 times 20 is 40 plus 60 is 100. So we would be going with Little Squeezers again. Because it's $108. So again, just recapping, you're comparing multiple representations using a rule to kind of answer and analyze some questions. And this will make more sense in the next chapter that you're going to be tested on, but this is a starting point where we have our rules and we use them.